So now if you wanted to use a calculator for this, and you can actually type in, like in the L2, you type 1.13 times 342, bam! So you don't have to do it like separately. What do I want L3 to be?
Minus 1 minus 2.
So O minus
Yeah, so where's O? L1 minus
L2
L2
squared.
square.
Store L3
Bam.
divided by L2.
Blot all that out. And then the next one would be, yeah, L3 divided by L2. Go bam.
No, I'm just going to write that by hand.
Blah, blah, blah. You write them all in there. So, I mean, to check yourself, you could add these up, you could add these up. These should add up to be close to 0, depending on how much you round. And not these, I'm sorry. Before we squared, they would add to be close to 0. The only one I really need to add up for the formula is this last guy. Everything else is kind of building up to there. Yeah?
How, with this kind of thing, does it matter the decimal places? Or, like on the last one, it's like,
Yeah, so
do you want like 4 or 3?
I would put as many as your calculator shows you.
Okay.
Yeah. Just to be on the safe side. Yeah. Just don't round into whole numbers. I mean, believe it or not, that could throw it off quite a bit, one side or the other. So now, how do I get the sum of this one? I could do it 2 ways. I'm just going to go stat, calc, one of our stats on L4. I don't know if you guys remember that. It's going to tell me a lot of shit, but the only one I care about is the sum. Is that what?
That's what I was talking about.
How do you mean? Sorry.
Like, do you want all that?
No, I just want.
Well, no, that one I don't care. It's
That's what I mean.
0.975.
That's fine. Okay.
Yeah, that's fine. Okay. That's kind of like step 4 from our normal hypothesis test. That's kind of like our chi-square star. You want to get crazy? Now, I don't say what alpha is, so what is alpha? Beautiful. So how do I get my chi-critical? What's my degrees of freedom?
4.
That's my categories is 4, so my degrees of freedom is, I'm sorry, here's 5. Think about the last one. Degrees of freedom is 4, 0.05 alpha, 4, is that what we had earlier?
Yeah.
Yeah. 9.488 again? Okay. And our chi-square was 6.975, so we only made it to there. There's the rejection region right there where we can say we found evidence that they're not the same. Did we find evidence here? No. So we have not found evidence to say that these don't follow this expected distribution. That we can't say that the grades don't follow this distribution. I'm really sorry if you have trouble with double negatives, but to be accurate in statistics, you just have to do it. This is not proof that these grades do follow this. I can't say that. But it's not proof that that they don't follow this. I love it. That's the way we have to say it. So we have not found evidence that these grades don't follow the expected pattern. They were close enough that any of the differences could have been attributable to normal variation of stuff. It wasn't so far away that you go, oh shit, it can't be the same thing. All right, so let's do this. Any questions on that? Kind of process there. Hopefully you've used the lists enough in your calculator to help you. To do what, sorry? Do you have to draw this? Not really. It'd be great if you would, but you could do the whole thing without it. It's kind of a nice visual, just like it was on the hypothesis test. Okay, so let's put together our formula sheet for the final. Even though I know you can just bring in all your formula sheets, I like to do this anyway because it kind of reminds you of everything that has happened. So, on the final itself, there could be problems related to the definitions and stuff from Chapter 1. There's no formulas in Chapter 1. Chapter 2, I will tell you this. I'm not going to ask you to construct a histogram. I might give you a constructed histogram and ask you questions about it. You understand? Okay. And there weren't many formulas besides the one you needed for constructing a histogram, like class width. So, no formulas yet. Chapter 3, well, at the end of Chapter 2, we of course get this good old dude here, right? And just to remind you guys also, I'm not going to make you do the full table for standard deviation, right? I'm going to write this, but I'm going to write it over here. Remember when we had to do... Right? Remember that? Remember those days? They're gone. Okay. Okay, so for some of you guys, I'm halfway reasonable. Oh, well, he finally lets us just use a button, script. You got to at least go through that a few times just to see what goes into making something, so you have a connection to it instead of just number comes popping out. Let me see. Blah 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 blah. All right, and then Chapter 3 is the probability section, right? That's probably A or B. What's probably an A or B? Basically, it involves what operation? Or is basically add. Right, you got to subtract off any that are both because you added them twice. Okay, so often I call or the nice bouncer. I don't know if I described it like that with you guys. You could have a lot of money. Nope. Or you can drive a nice car. Nope. Or you can have nice clothes. Nope. Or you can know Joe. Yay, I can go in. So more and more and more people. Or makes things bigger. And makes things smaller. And is the multiplication. And this is related to if I pick 2 cards out of a deck of cards and without replacement. What's probably they're both kings. It would be 4 out of 52. 4 kings out of 52. Throw that one away times 3 out of 51. Because king, given that I already got a king. That's why the second probability changes, because it's dependent on what happened. So that's what this formula really is related to. That we use this formula directly without you guys even knowing you're doing the damn formula. So what's the formula for this then? Let me turn that around just to be that guy. A and B divided by?
Probability of B.
Yeah, the given. I like it. The given goes on the bottom. Let me see. I think that's it for probability section. And then we get into, then we get into this stuff. I'm going to need more room. I'm going to need a bigger board. All right. Well, let's keep going here, Jeff. Sorry. Remember this stuff? I love it. You're like, you did that shit. So this is when I give you x, p of x. You probably use the formula that's got x and p of x in it. The standard deviation of variance, I'll put it as variance. Hopefully that sort of looks familiar. So this is general probability distributions for discrete problems. And then we have binomial probability distribution. Yeah, they're big X. Yeah, they're little c. This n choose x, p to the x, q to the n minus x. That thing. Where people are still trying to tell me, I showed you my work, I told you that I pushed this button. It's not showing me where. What was the mean for NPQ problems? NP? I love what it is. Standard deviation was NPQ. I love it. All right. And then we got into normal distribution, which came back to this formula, of course. And then you use the z-score chart to do your stuff. But then we also got into central limit theorem. CLT. What was that one all about? You're like, I don't know, man. It's not test day. Stop asking me questions. So the new thing is, I now have sample means because I'm taking samples. And of course, sigma x bar, what's the formula for sigma x bar? Yes. So it's the old standard deviation divided by square root of n. So you guys look at this is day one. This is good shit. It's all new to me. Let's see, where am I at? So that's central limit theorem. So this is for individuals, and this is for groups of size n. You probably want to put here for yourself this formula to remind yourself that if it's S or sigma, you gotta freaking change it. This is still the one for individuals, so if I want one for groups, I still have to change it, even if it's S. You're looking at it the wrong way if you think you don't have to change it. All right. Continuing over here. Then we moved into confidence intervals. All right, so we got their standard 5 formulas there. Got it. Bam. Bless you. Disadvantage. All right. Hopefully those look familiar. That's not too long ago. My little disclaimer is you better double check these against something written with a computer, right? In the book or something. I don't want you telling me, well, this is what it looked like. Should have gotten points on. No, stop. This is me telling you what you're allowed to have on the formula sheet. You better make sure you get the right formula down. That was neat. All right, so that's chapter 8, confidence intervals. What are these two formulas used for? I like it, finding n. So how large of a sample do I need to be within so much? So when you're dealing with percentages, you better change 1% to 0.01. But please, dear God, this is just pure, I want to be within 10 grams. Don't change that to 0.1. That's not a percentage. It's just 10 grams. I want to be off by 10 grams. That's the error. Exactly. All right, let's see. And then we get into hypothesis tests. So we got this middle part, right? All right, so this, yes. And the new stuff with the hypothesis tests would be, if you want to, you could put that down there. It's the same formula, right? But the new stuff would be like the p-hat stuff. And then the double stuff. And then we got into linear regression, correlation, which is basically all in the calculator. And then you got the chi-square stuff. Stuff we just did today. Yes?
What does the square root of the first one say?
Oh, here? PQ over N. You'll notice it's the same thing here, except with the hypothesis test, we assume that the P from the claim is the right one. We don't have to use the hatted ones, right? Oh my God. And did I already say this earlier? The final exam, all my finals are on Monday. This one I think somebody found out earlier, it's 11:35. It's 11:35 on Monday. I'm going to remind you guys again that fact on Wednesday. If somebody shows up at 12:30, they have given up almost an hour. They said, I don't need that hour. I'm not going to give extra time if somebody comes late. That's too damn bad. So don't come late. Come early, right? I have a final right before that one. So I'm going to have, on Wednesday I'm going to give you, I'll tell you my office hours. It's going to be that morning before my 9:25 final. I'll have office hours. All right? Yes?
Can we go over the chapter 2 where it's probability of A or B, probability of A and B?
Sure, yeah.
Can
Okay.
we go over like a couple second problems?
Yeah. So we got this stuff up here. All right. So I kind of like problems like this. So I could do an example like this real quick. So you ask men and women a question. So I'll let your own imaginations come up with what a question might be that would fit the pattern of answers. And I could ask you questions like, what's the probability if I pick one person? What's the probably pick somebody who is male. Okay, start nice and easy. So what do I need to do first? I'm going to give you those blank boxes to try to spur your memory. I've got to, of course, total everything so I can answer these questions. Probabilities are all based on the total number of things. Ways to do something divided by total ways to do anything, right? So here I got, what is this? If I add these up, that's the total number of people that said yes. I like it. 39 people said no. 35 people were men, and 36 people were women. And when I add that up, I get 71, and it gets 71 this way also. Don't add these to these because then you added everybody twice. That's a little crazy. Okay. So it's probably I pick a man. 35 out of 71. I like it. So what's probably I pick a man or somebody who said no. No, that is the probability I pick a man and they said no. So and is very restrictive. In the English language, we use and in several different ways. Math says, screw that shit. Let's say and is restrictive, not inclusive, right? So if I said you and you and you and you and you and you, every time I say and, I'm like getting a bigger group. That's not the way it works in mathematics. If I said you have to have a above 3.5 GPA and you have to be a forestry major and you have to have a quarter Cherokee Indian blood and you have to get a scholarship. Are you guys with me? Fewer and fewer every time I say and, fewer and fewer and fewer people can do that because they have to do all of them. That's the way and is supposed to be, really. That's the way and is in mathematics. So and is always going to decrease the number. Because not only do you have to be a man, you also have to said no. It's for the and part, right? So that would be 28 people match that out of 71. What would the or be? You could be a man or somebody who said no. Yeah, so if you do 74, how many did you add twice? Those 28. But you could be smart about it. You take all the men, and how many no's did you leave out? 11. So then you get 46, like our few people say. 46 out of 71. Either way you do it, you get 46 out of 71. So, or will always make it bigger if it changes it, and will always make it smaller if it changes it, because it's more restrictive. Or is like you or you or you ever, just come on in. Is that sort of like what you're asking? Or?
Yeah.
Okay. All right. Anything else you guys want to look at today? Yes.
Just along with the used ones, you do one about like given, like when the
Yeah.
denominator changes.
So here, if I said, what's the probability that they said yes, given that they're a woman? So what do I know about the person? They are a woman. I love it. What's the probability they said yes? So I have no idea what they said. Given they're, okay, I know they're a woman. So what's going to go on the bottom? 36. There's 36 people it could be because I know it's a woman. Out of those 36, how many said yes? 25. I like it. And what's the probability that somebody said yes? Period. 32 out of 71? Somebody help me out. What's 25 divided by 36 roughly? I love how they're both squares. I like that.
About 70%,
0.69 something? Or, okay. And then 32 divided by 71?
0.45.
I like it. So, did the probability that somebody said yes was that affected by the knowledge of their gender, of their sex? Right? Yeah. Probably somebody said yes is 45%. If I know they're a woman, did they said yes change? Yeah, it did. Therefore, saying yes and being a woman are dependent. It depends on if they were. What's probably if they said yes, given it's a man. Given it's a man. 7 out of 35. What's 7 divided by 35? 20%. So look, probably that somebody said yes is 45%. Given it's a man, it's 20%. Given it's a woman, it's almost 70%. So does it depend on which sex you are? Yes! So this is dependent. You can't just go, well, yes is different from woman. How does that show any interaction between the two? You got to let yes and woman interact. That's this. That's the given. That's how they interact with each other. So did it change from what it is standardly? Yes, it did. I love making the words standardly. Oh my God, now I feel a little bit connected to our president. Bigly. It's affected us bigly. Okay. What time we got? Yeah, it's up to you guys. We can keep going a little bit, or we can pick this up next time. Yes. What the hell's wrong with you? Are you kidding me? Oh, that's just double emphasis asking a question. What part of chapter 10? Or just everything? Okay. Yeah, number 5, that's my 8th puberty there. Number 5 is the linear correlation regression problem on the practice final. I'm kind of happy about this. I used to be the second to last data point there. I used to live 1.5 miles away from Bronx Pizza. I think can you tell I don't know, yeah, this might be the first time you guys looked at this problem, but I was trying to see if there's a correlation between how far away you live from Bronx Pizza. How many of you guys know Bronx Pizza? Anybody? A couple of you guys. The rest of you guys like Chicago Pizza. It's lasagna, but sorry. Yeah, Bronx Pizza there. I used to think they must have put crack in their dough or something. My God, it was yummy. Yeah, just did some of crack. Anyway, so I just to give you a little hint about part A on the problem before I get to something specific, where's the weight in this problem? Which list would it be if you put these in the lists? Where's the weight? Is it list 1 or list 2? Problem number 5. List 2, because it's the second one. Part A says make a confidence interval for the true mean weight. The mistake people make is they just hit 1var stats. 1var stats defaults to list 1, so that would give you stuff about miles away from Bronx Pizza. You got to make sure you get the data for our weight. Right, you got to do list 2 for 1var stats. Are you going to use T-scores or Z-scores for 5A? T-scores, why? Yeah, don't know sigma. I only give you sample information. You have a clue about what the population is, right? Okay, so you got to use T-scores. I like it. Now, so the whole idea of the correlation regression thing, you can do it all in the calculator. You don't have to worry about the formula that they show in the book. List 1, list 2. I don't know if we want to do... Do you have trouble with remembering the calculator methods, or do you just want to get a problem done and look at it? Okay. I think I gave somebody that, but remember, all the calculator procedures are up on the website. It's called the TI Calculator Guide. They're there. So that's a part of it, is the steps for doing linear regression correlation. Let me see. I don't know if I want to do an entire problem right now, but I will have this done on Wednesday. You'll be here Wednesday? So we'll probably do at least this one and another correlation regression problem, because you're going to have to come up and show me your data points and your line of best fit on the day of the final. You have to come up and show it to me. So we will do a couple examples of that come Wednesday. Okay? I like it. All right. So Wednesday I'll have the answer key for this practice final. And the final's Monday.
It is.
Huh?
It is.
Did you miss that discussion earlier? Shits is right. Starts at 11:35.
You canceled the quiz?
I was starting to panic. I was like,
I know, right? Yeah. You're all did it.
You're all funny. You should be angry. Like, I want more grades.
well, yeah, exactly is due on the